And this is my submission for the NP Complete Problems assignment for CST 201. In this video, I'll walk through a program I created in Java that solves a lecture scheduling problem at GCU using a graph coloring technique. The purpose of this solution is to determine two things. First, the minimum number of distinct time slots needed to avoid any overlap of lectures with shared students. Second, the minimum number of unique conflicts between lectures, which we approximate by counting edges in a graph. The input to this program is a flattened adjacency matrix represented by a string of 49 digits. Each one means that two lectures have at least one student in common and should not be scheduled at the same time. The 7x7 matrix, which I parse into a 2D array, is represented here. To solve the first part, I use the greedy coloring algorithm, which is right here. The algorithm iterates through each lecture and assigns it to the lowest numbered time slot or color that doesn't conflict with any already colored neighboring lectures. This approach doesn't guarantee an optimal solution, but provides a fast and often effective approximation. To solve the second part, I count the number of unique letter conflicts here, which is equivalent to the number of unique edges in the adjacency matrix. Each edge represents a different pair of lectures that must be kept in separate time slots, and we treat each as a different student conflict. I'm going to go ahead and run it here. Here's the 7x7 adjacency matrix printed out for visual confirmation. Now the algorithm runs and reruns two key values. First, the minimum number of time slots needed, in the case, for example, 4. That means we can schedule all 7 lectures using 4 distinct time blocks without conflicts. Second, the program reports the number of unique conflicts. For example, 11 pairs of lectures share students that need to be scheduled at different times. These results demonstrate the reduction of scheduling problems into graph theory model, which is typical of NP complete problems. In conclusion, this project shows how to apply computer science theory, in this case graph coloring, and fundamental programming techniques to solve a real-world problem efficiency. The greedy algorithm provides a fast approximation of the chromatic number, and edge counting gives us an estimate of conflict complexity. I've kept the video professional and organized as is required by the rubric, and I hope this clearly demonstrates the logic, structure, and effectiveness of the program. Thank you for watching. I appreciate your time, and thank you for all your help this semester. Aloha.